Welcome everybody to our sixth and final lesson about statistics, correlation versus causation. So far, in a short amount of time, we've learned a lot. We've learned about two-way tables, we've learned how to use them to determine relative frequencies, we've found out about lines of best fit. With those lines, we've made some predictions. We've evaluated lines to see how close they've actually matched the data. And then finally, we've described the type and strength of correlations. Before I tell you what we're learning about today, I want to share something with you about an event that happens every year called the Scripps National Spelling Bee.
From the bright lights of Broadway to award-winning books to the glitz of Hollywood.
You want to win what?
I want to win a national spelling bee!
More and more Americans are being swept up by the drama of the bee. The National Spelling Bee has grabbed hold of the American public. Listen to the buzz.
It was May 29th, 2009, and it was down to one word to see who would win the annual Scripps National Spelling Bee. You may have seen this event on television, probably not in 2009. But in 2009, Kavya Shivashankar was up and ready to spell her final word.
Laodicean.
Laodicean. Can I please have the definition?
Lukewarm or indifferent in religion or politics.
Laodicean. Can I please have the language of origin?
It consists of a Greek geographical name that went into Latin plus an English combining form.
Laodicean. Is that the only pronunciation?
Yes, Laodicean.
Laodicean.
Worked so hard for this for so long.
Laodicean. Laodicean. Laodicean.
We have a champion. Now you see some emotion from Dad. What a team they have been for 4 years. Incredible what she's pulled off.
Now you probably noticed that the final word, Laodicean, contained 9 letters. That same year that Laodicean was the final word in the Scripps Spelling Bee, 2009, 6 Americans died from venomous spider bites.
I want you to be on the lookout for a new breed of spiders here in Oklahoma.
It's a brown widow spider.
Is there a connection between these two? Maybe. You'll find out today. Today, you're going to be exploring 3 examples of correlation. You'll be asking, what is causing what here? Then, you'll learn why math and science actually need one another quite a bit. Finally, you'll engage in a review of everything you've learned so far about statistics. So now, I'm going to actually send you into Desmos. You're going to spend roughly the next 15 to 20 minutes on the first 3 scenarios, seeing if you can figure out what the 2 variables have to do with one another. Have fun, and I'll see you back here in a little bit. The activity you just worked on asks you to think like a mathematician. Namely, it asks you to think creatively. To answer the question, which one caused the other? We're going to be looking at the first scenario, spider deaths and spelling bees, meaning the number of people who died by venomous spider bites in a given year and the length of the winning word from the National Spelling Bee. And you want to know which one caused the other. Well, we want to know why these 2 are correlated. Maybe A caused B. Maybe the number of deaths by spider bite somehow caused the spelling bee organizers to make longer words. Maybe B caused A. Maybe the longer words in the spelling bee gave spiders more time to bite people while they were watching the spelling bee. Maybe there's something else that's causing both of these to go up. I don't know what that would be, but you could probably think of something. For example, in the case of crime rates in coffee shops, they're both likely caused by the fact that there are just more people in some areas. More people means more coffee shops and higher crime. And then the last possibility is that there is no causation at all. Neither one of these is causing the other. That's called a spurious correlation. I took this example from a website called Spurious Correlations because it seems like a pretty clear example where one actually doesn't cause the other at all. They just happen to both go up and down at the same time. Sometimes that happens. In a world with almost infinite access to data, you're going to find some coincidences. The reality, though, is that math doesn't know which one caused the other. Math can't tell you. This is why math and science need one another. That's why they're best friends forever. Math can tell you if there is a correlation, can draw a line of best fit, can find a correlation coefficient, but math alone cannot tell you if there is a causal relationship, meaning if one causes the other. To prove causality, math actually needs science, because science can show you how one variable could influence the other, how it could make the other happen. We'll talk about climate change in a little bit. That's a clear area where science has shown very clearly how one of those variables could influence the other. But science can't prove that there's a correlation, so it comes back to math. Math needs to prove that there's a correlation for science to even decide to look into whether one causes the other. So let's talk about climate change for a second. It's a bit of a hot topic. Get it? Aha. Because it's hot. So we want to know, why are carbon dioxide levels and global temperature correlated? Which one is causing the other? So here are the same possibilities. Maybe carbon dioxide causes temperatures to rise. Scientists have studied to see if that happens, and it turns out in isolated experiments, that's exactly what happens. So yes, that is very likely. Maybe high temperatures cause high carbon dioxide concentration. Scientists have studied that too, and they've also shown that that happens. Those two happening together means that there's a cycle. It means that as carbon dioxide rates go up, temperatures rise, and then carbon dioxide rates go up even more, and then temperature rises even more. It's a spiral. It's going to get really hot. It's possible that something else is causing both high carbon dioxide levels and high temperatures. Scientists have not found any evidence of that. It's also possible that there's no causation at all, that it's a spurious correlation. The evidence overwhelmingly points to the fact that there is a meaningful causal relationship here. So scientists have almost entirely disproven that. To sum up scientific findings on climate change, 97% or more of actively publishing climate scientists agree climate warming trends over the past century are extremely likely due to human activities, meaning humans producing more carbon dioxide has led to an increase in temperatures. Or, to summarize, yes, it's real. So whenever you hear arguments that scientists haven't proven that climate change is because of human activity, it's because it's impossible for them to prove it. But when 97% of the people who spend their entire lives studying exactly this question agree that one is causing the other, we should listen. In fact, it is true that correlation does not imply causation. We can have correlation and neither one causes the other, like spiders and spelling bees. But exercise is positively correlated with good health. You should probably exercise because it probably causes good health. Drinking water is negatively correlated with dying of thirst. You should probably make sure you're drinking liquids, like water. Studying is positively correlated with grades because studying probably causes grades to go up, and so on. There are so many examples. What I'm trying to tell you is correlation doesn't mean that there's necessarily causation, but it doesn't mean that there isn't. You should still make reasonable choices. So that's it for statistics. Here's what I want you to really take away in terms of how you think about the world. 1, be skeptical. If somebody tries to tell you something and it doesn't seem right, it might not be right. 2, know how skeptical you should be. If you see that there's a strong correlation between two variables, know that maybe you could be a little more confident. But if there's a weak correlation, maybe just tell people, hey, you know what? I'm going to include some doubt in this. It probably seems like these two are related, but we're not entirely sure. And that's fine. You should question causation. When people say that 5G caused coronavirus because the graph shows that they both went up at the same time, that should set off alarm bells in your head. And you should say, wait a second, maybe they both just happened at the same time. Continue to drink water, exercise, and get plenty of vitamin D. Basically, continue to make reasonable choices, just like you always would. Don't get so doubtful that you start questioning even things that you know for sure. And that's all we're going to do with statistics. You're going to go back and review for a little bit in Desmos, and then I'll see you here tomorrow to start our overall review of the year. Bye.
New breed of spiders here in Oklahoma.